Hello everybody and welcome to our experts webinar. My name is Kerry Moulds and I'll be walking you through our services here at Socratek's Sustainability Division. We have got a Q&A session at the end, so if you'd like to ask any questions, we can answer those at the end of the presentation. So as you can see, our service offering in the sustainability team is split into new construction projects and the existing built environment. So the range of services that we offer can cater for all building needs and requirements. In the UK, a Brooker report, which stands for the Building Regulations UK Part L report, is required to demonstrate compliance with the energy performance standards set out in Part L of the building regs. Part L specifically deals with the conservation of fuel and power, which ensures that buildings are energy efficient. The report is needed in various different scenarios. So those scenarios would be for new non-residential buildings. So any non-residential building that is, whether it's commercial or public buildings included as well, a Brooker report must be submitted as part of the planning and building control process. It also covers any major renovations. So any non-residential buildings that are undergoing a major renovation that can significantly affect its energy performance, a Brooker report will also be required to show that the renovation also complies with Part L. Sometimes large extensions will require a report, especially if the extension will increase the building's energy use. And also if a commercial building is going through a change of use. So any building that's been repurposed will also require compliance and for that compliance to be in line with the energy performance regulations. And lastly, shell and core buildings. So any buildings that are built to shell and core where the structure is completed but the internal fit out is left for the future tenants. This would also need a Brooker report. The main purpose of this report is to demonstrate compliance with Part L. The report assesses whether the building's design meets the energy efficiency requirements of the building regs. So this includes things like the thermal performance, air tightness and the efficiency of the building services, so the heating, cooling and lighting. It will also estimate the building's CO2 emissions, so it can calculate the carbon dioxide emissions from the building based on its energy use, and it will compare it to a notional building that will meet the minimum requirements. The actual building, therefore, must perform at least as well as the notional building. So the Brooker report is often a precursor to obtaining an EPC, which is also required for commercial buildings when they are built, sold or rented out. And some factors that come into a Brooker report will be things like the TER versus BER comparison. So the report compares the target emission rate, which is the TER, which is the maximum CO2 emission rate allowed by regulations, with the building emission rate, the BER, which is the estimated emission rate of the actual building. So the BER must be lower or equal to the TER. The report also includes details on how the building's design performs in terms of energy consumption for heating, cooling, ventilation and lighting. And if the building design doesn't meet the required standards, then the Brooker report may include suggestions for improvements so that we can be brought into compliance. So in short, the report ensures that non-residential buildings are designed to be energy efficient. So this is going to contribute to the UK's wider efforts to reduce carbon emissions and conserve energy resources. So that leads us on to SAP calculations. So SAP stands for Standard Assessment Procedure, and these are all about assessing the energy performance of homes, so it's residential buildings. So they're required to comply with Part L Volume 1 for dwellings of the building regs, which focuses on conserving fuel and power. So a SAP calculation is needed for every new residential building, so every new home. It is required at the design stage and then again when the building is finished and we produce the as-built version of the SAP. It also covers any conversion. So if a building is being converted into homes, so for example, you have a barn conversion or a commercial space, then a SAP will also be required. And much like the Brookall, it also covers any major renovations that is taking place on a property and any large extensions. Specifically self-build projects, so if anybody's building their own home, then they must get a SAP calculation done. And also, it can also cover social housing. So a lot of social housing projects will need to meet specific energy efficiency targets. So SAP calculations are important to make sure that they comply with the building regs. After the SAP assessment, you'll get an EPC, which will rate the home's energy on efficiency on a scale from A, which is best, down to G, which is worst. The SAP calculations also ensure that the CO2 stays below the target levels, again helping the UK meet its carbon reduction goals. It also evaluates the insulation and air tightness and heating systems, windows, lighting, and any renewables, so anything like solar panels that are installed, which will all assess the home's overall efficiency. So as mentioned, there are 2 stages to SAP calculation. There's the design stage, which must be submitted to building control before the building construction starts. And then again, the as-built SAP, which will be after construction. So a final SAP calculation will then confirm that the home's actual energy performance and EPC is issued. So what's involved in a SAP calculation? So we look at things like the thermal efficiency of walls, floors and roofs. We look at the U values for the windows and doors and how well they'll keep the heat in. We also look at the heating systems, so the ventilation, lighting, and any renewable energy sources. We also look at air tightness to reduce the heat loss. So the SAP calc will ensure that the homes are energy efficient. So this is going to be promoting the sustainability and reducing the carbon footprint of the new or recently renovated property. But without the SAP approval, you won't get building control sign-off. So it's essential that this is carried out to complete the process and to make sure that the project is actually finished legally. So Part O calculations. Part O was introduced to tackle the growing problem of overheating in homes, which became more urgent due to climate change and also the trend towards creating an airtight building. So it's since June 2022, I think it was when it came out, it's been mandatory for all new residential buildings to comply with Part O. So Part O focuses on reducing the risk of excessive heat in homes. So particularly in high density areas and cities where the heat tends to build up. It applies to new homes, apartments, care homes, as well as buildings undergoing major renovations or conversions. The aim of this modelling and calculation is to make sure that the design prevents overheating, and there is 2 different methods that we use to do that. So there's a simplified method, which is ideal for most homes, and it will look at things like the window size, the shading and the ventilation. So example strategies would be to have smaller windows, external blinds, and ensuring cross ventilation. And then alternatively, there is the dynamic thermal modelling. So this is really aimed at more complex projects or high risk areas. And this method uses software to simulate how the building will handle heat under different conditions. So having these calculations carried out is really important to health and comfort. So overheating can cause serious health issues, especially for the vulnerable. So it's important that we keep our homes cool to make sure that people stay safe and comfortable. And also as temperatures rise, homes need to be future-proofed to handle any future heat waves. And by using the natural cooling and ventilation reduces the need for any energy-intensive air conditioning to be installed. So it's helping to keep the carbon emissions a lot lower. There are some factors involved in Part O. So solar gain, so we're minimising the heat entering through the windows, the shading and glazing. So we look at using external shades and energy efficient windows. Ventilation, so ensuring that we've got proper airflow, whether it's natural or mechanical. The thermal mass, so we look at the materials that absorb and release heat to help keep the temperatures of the building stable. And we also look at the location and the orientation of the building. So homes in cities that have got lots of sunlight are going to be at a higher risk of overheating. So just to summarise it, the Part O calculations will ensure that the homes are designed to stay cool, promoting comfort and sustainability, and they're also a legal compliance in line with the modern building regs. Part G water calculations are all about making new homes water efficient. So these calculations are required to show compliance with the Part G of the building regs, which limits water use up to about 125 litres per person per day. Sometimes, and in some areas, those limits are a little bit stricter at about 110 litres. So for new homes and conversions into residential properties and large renovations that are affecting the water systems, and any self-build projects are all going to require these calculations to be carried out. They ensure that the homes are built with efficient fixtures. So we look at things like the taps, the showers and the toilets, and also the appliances to make sure that they use less water. So by reducing the water consumption, it's another requirement of your building regs. So to make sure that you can get the sign-off required for your project. So as mentioned, we will look at things like the fixtures and the fittings of the building, the appliances, because once you start adding all of these up in a building, these will all determine the quantity of water that's going to be used. So by carrying out these calculations, we can ensure that the building meets the efficiency targets. Okay, our next service that we offer is daylight and sunlight calculations. So these are all about making buildings getting enough natural light. So it's important not just for the people living or working in the building, but it's also important to meet the planning guidelines. So any new developments, now this is whether it's residential or commercial, if you're doing an extension or a renovation that might affect the amount of natural light coming into your space. And also when you're building something new that could also impact the neighbouring property's light as well. So they're important because natural light is essential for creating comfortable, healthy spaces, as well as meeting the planning requirements and avoiding overshadowing nearby buildings. Plus, the more daylight we can get into the building, the less need there's going to be for artificial lighting, which again is all going to go hand in hand with saving energy. So to carry out these calculations, we measure the amount of daylight coming into an interior space, and this is known as the average daylight factor. So we will check the sunlight exposure for windows and outdoor areas and ensure that no significant loss of light is going to occur on the neighbouring properties. We also carry out thermal bridging calculations. So these can help us identify areas in a building where heat escapes more easily. And the areas of the building where this can occur are often at junctions where different building materials meet, so walls, floors, and around windows, those types of areas. This service can be required for residential and commercial buildings. And again, whether it's an extension or a renovation, this can apply. So it will also make sure that the building meets Part L of the building regulations, which focuses on the energy efficiency. So if we can reduce the heat loss, we can improve the building's overall efficiency. It can also help prevent cold spots, which can create condensation and mould, which making the home or building ultimately more comfortable and healthier. We calculate, to carry out this service, we calculate the PSI values. So this will actually tell us then how much heat is being lost in a given area. And then finally, we can recommend maybe some design changes or some insulation in that area, which will reduce the heat loss and improve the building's performance. So similarly to the thermal bridging, this is another service, condensation risk analysis. It is slightly different, but it kind of goes hand in hand with the thermal bridging. So the condensation risk analysis is about figuring out where the moisture could build up inside a building that can cause condensation. And if this isn't addressed, it could lead to serious issues like structural damage, mold growth, and also poor air quality as well. So this is something that we can look at for new builds and major renovations, especially in well insulated and airtight buildings. So the more we are making a sealed building, so on one hand we're making it more efficient by keeping it airtight, we can then actually on the opposite side create an issue for condensation. So it's something that's important that gets looked at. We also want to make sure that it's that we're staying within the building regs and making sure that that building is going to last long term and not any future moisture problems. So by carrying out these calculations, we can make sure that we're protecting the health and the comfort of the people in the building, and also making sure that the indoor air quality is safe and free from any excess humidity. Making sure that the building stays in good shape, really, and complying with the regs and extending its lifespan. So as part of carrying out these calculations, what we look at is the dew points, which is the temperature where the moisture in the air will condense into water. And we can check different areas of the building to see where this might happen. But we do pay special attention to the thermal bridges because this is normally where this situation is going to occur. So where the heat loss can then increase into condensation risk. And if this does happen, we can recommend strategies like better ventilation, improved insulation to control the moisture and prevent the condensation occurring. We also have our service of energy statements for planning applications. So an energy statement is a document that explains how proposed development will meet the energy efficiency and carbon reduction goals, which is important for getting planning approval. So this would be required for any new developments, major renovations or large-scale projects as part of the planning process. Local authorities want to see that the project will meet the sustainability targets and contribute to the carbon reduction goals. So it's pretty important because it will show how this development will reduce the energy consumption and carbon emissions, which is not only key for meeting the national requirements, but also the local climate requirements as well. And it will help support the planning approval by showing that this project has a commitment to energy efficient design and the use of renewable energy. So as part of this service, we will look at the building's overall energy demand and suggest ways to reduce it. So things like the energy efficient technologies, so better insulation, improved glazing, energy efficient heating systems, look at any options for renewable energy like solar panels or heat pumps. And the main goal for this really is to show that the development is going to comply with the standards and fall in line with Part L of the building regs. Air testing or air tightness testing is also something that goes hand in hand with Part L. So this measures how well a building is sealed to prevent air leaks. So it checks for drafts and heat loss, ensuring that the building is energy efficient. So this testing is required on any new builds and certain renovations, depending on the size of it, or anything that needs to comply with Part L of the building regs. This test is normally carried out at the end of a construction project. So we need to make sure that the building is already properly sealed before we look at carrying out the air leakage. So we can help reduce the heat loss of the building, which in turn will lead to lower energy bills and reduce the carbon emissions. And it also forms a major part of the achieving a good EPC at the rating at the end. So in order to get your EPC rating, you need to have your air test carried out first. So what's involved in an air test? So we carry out a specialised test which rates the air leakage from the building. So we will highlight areas where sealing or insulation may need improvement. So this can specifically be around doors and windows, sometimes around sockets within the building. And the goal is to ensure that the building meets the required targets and standards for efficiency and comfort. Thermographic survey. So again, these kind of go hand in hand with the air tightness. It's another tool that we can use. So especially for new buildings. So these involve using an infrared camera to detect the temperature variations across surfaces, which can reveal hidden issues. So by using the infrared technology, we can create a heat map of the building. So we can identify the areas where the heat is escaping, or where maybe there's been a break in the insulation and it's not continuous throughout a part of the building. It might be lacking a little bit. So this is a completely non-invasive and very quick method, and it's ideal for new construction as well. We can also use drones if the building is particularly big or tall, if it's a multi-story building. And by carrying out a thermographic survey, the contractors and the builders can ensure that the building is energy efficient and ready for occupancy. It also helps prevent costly repairs in the future by catching the issues early on and at the very, very beginning. And in some cases, it's sometimes used just as a final quality control step before the building is handed over to the owner. The best time to conduct these surveys, and this is the only sort of downfall with thermographic surveys, is to carry them out between September and May. And the reason for that is because there must be a 10-degree temperature differential between the internal and the external across the entire envelope of the building. So it's important that if a building does require a thermographic survey, that is booked in, because it's an incredibly busy time of year for those surveys to be carried out, as we've only got a short window in which to do it in. So as mentioned, the primary tool is the infrared camera. We then pair that with some software which will help analyse the data and provide any insights to any anomalies found. Okay, that leads us on to another service, which is a BREEAM certification. So BREEAM is something that was launched in about 1990 by the BRE, and it stands for the Building Research Establishment Environmental Assessment Method, i.e. BREEAM. So thank goodness they abbreviated it. The certification was created to set a standard to improve buildings' performance at every stage of the build life cycle. So it starts right at the beginning at the design stage, goes on through to the construction, and then on handover of the building, and it also then can be continued on to in use as well. You can have in use certification. And also refurbishment. So there's also a specific category for refurbishment projects. So a building that's got BREEAM certification or is targeting BREEAM certification is not just recognised as having like genuine green credentials, but it's also has improved sustainability for the wider environment, because there were aspects of the environment that the building sits in as well as the building itself. So the benefits of having a BREEAM rating, well, it's going to improve the energy efficiency of that building, and it's going to minimise the harmful carbon emissions that the building is going to create. It's going to minimise the operational pollution of that building. It's going to demonstrate that the materials used for the construction of that building are sustainable, and that the building is going to continually to perform over a period of time. But over and above all of that, it also increases the market value of the building as well. So this is particularly important for the developer or the owner of that building. So buildings with BREEAM ratings do yield a higher percentage in their rental income. There is also the WELL building standard. So this is increasing in popularity now across the UK and Europe. And this certification focuses on enhancing the health and well-being. So currently there's approximately between sort of 880 projects, I believe, that are currently undergoing WELL assessment, and at least 50 projects so far in the UK have been certified. So whilst BREEAM focuses on the environmental sustainability, the WELL building standard is dedicated to the human health and the well-being. So there are some crosswalks between BREEAM and WELL. So the philosophies behind both of them do naturally align. They're both built on the belief that buildings should be energy efficient and resource conscious. but also providing healthy environments for people. So the alignment ensures that both systems complement each other effectively. And not only is it that the philosophies align, but the standards themselves are also designed to work in tandem. So by integrating both BREEAM and WELL into a building project, we can maximise the overall impact and create spaces that are not just environmentally sustainable, but also supporting the human health and productivity and well-being. So this dual approach is becoming more popular now, and it ultimately is contributing to a brighter and healthier future for buildings and people. Okay, and that brings me to the end of our experts webinar. So thank you for listening, and please feel free to ask any questions.